Welcome to Chips of Math Physics. In this video, we shall be verifying the distributive law. Before then, I would like to say a big thank you to all our supporters, sponsors across the globe, all those who continue to use this means to touch the hearts of our students and to change their lives in one way or the other. Let us now jump into it. Today we want to verify the distributive law. So the question is, verify the distributive law. Assuming that we are given three sets, say we have set A, which is given by 4, 5, and 6. And we have set B, which is given by 3, 4, 6, and 7. And set C, which is given by 2, 3, and 6. So the question is, verify the distributive law. To do this, we must need to use the distributive property. The distributive property is a reanalysis problem, which is pure mathematics. It affirms that A, this set A, union B intersection C is equal to A union B, A union B intersection A union C. In other words, what we have just said, or what we have done, we have showed that A union B intersection C is contained in A union B intersection A union C. This is exactly what we have done. This symbol here simply means contained. So let us go ahead to verify the distributive law given set A, B, and C using the above properties. To do this, let's get rid of this. Our property says that A union B intersection C is equal to A union B intersection A union C. So now, what we are going to do is to take the left-hand side. Left-hand side. This is our left-hand side. A union B intersection C is the left-hand side. And here we have A. A is given by 4, 5, and 6. And this is in union with B intersection C. Our set B is given by 3, 4, 6, 7. 3, 4, 6, 7. And this set is intersecting C, which is 2, 3, and 6. If you observed, this is A union B intersection C, and in set A we have 4, 5, and 6, and this is in union with 3, 4, 6, and 7, which is set B, and this set B is intersecting C, which is 2, 3, 6. And we know how to take the intersection of the set. The intersection of these two sets are set B and C, which is this set. Let us rename it for clarification. This is our set A, this is our set B, and this is our set C. So A is in union with B intersection C. This is set A, this is set B, and that is our set C. So now we are trying to prove that A union B intersection C is equal to A union B intersection A union C. So let us take the intersection of B intersection C. The two sets that intersect here is 3 and 6, because we can only take one. The one that is in A is in B and is also in C. If you observe, we have 3 in B and we have 3 in C. We have 6 in B and we have 6 in C. So A union B intersection C will simply be 4, 5, 6. Then this is in union with 3 and 6. 3 and 6 here represent B intersection C. So therefore, what we will have here, if we arrange it according to, if we arrange this set systematically, we have 3, 4, 5, and 6. And this is what we got to be A union B intersection C. And this set must be equal to A union B intersection A union C. So now let's proceed to prove that this same answer we got for this, we are going to get for A union B intersection A union C. So now we are going to take the right hand side. For the right hand side, we have A union B. So set A is given by A union B. We simply take A union B. Three, 4, 5, 6, and 7. Union means that we are taking all the elements in A and the element in B. And we know that in A we have 4, 5, 6. In B we have 3, 4, 6, 7. So if we take it systematically, we will have 3, 4, 5, 6, 7 according to the ascending order. So this set represents A union B. So now it must be it is interceding A union C. So let us take intersection A union C. A union C will be 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. It is simply all the element in A and all the element in C. And we know that A have 4, 5, 6 and C has 2, 3, 4 and 6. So we take them according to the ascending order. We have 2, 3, 4, 5 and 6. Of course, we cannot repeat 6 twice. So we just take 1. That's why we have 2, 3, 4, 5 and 6. So let us take the intersection of these two. This set here, this is A union C. So now let us take the intersection of these two sets. The intersection simply means the element in this A union B that we can also find in A union C. The element in A, we have 3. And we have 3 here. There is 3 in A union B and there is 3 in A union C. So we have A union B 3, A union C 3. What's other element? We have 4 here and we also have 4 here. So we have 4. We have 5 and we have 5. We also have 6 and we have 6. We have 7 in A union B, but we don't have 7 in A union C. So therefore, our solution here in A union B intersection A union C is 3, 4, 5, and 6. And you can see that what we are verifying is that A union B intersection C, which we got 3, 4, 5, 6 is equal to A union B intersection A union C, which is 3, 4, 5, 6. So what we have in the left hand side is equal to what we have in the right hand side. And that is how we verify the distributive property, which we also call the De Morgan's law. See you in our next video. Otherwise, I wish you all the best. Augustine Galagash.